the components of the bike, classifying them and understanding the operation from each one, we began the second phase. At this moment, we divided the parts so that each member completed some, knowing severity, occurrence, detection from each one, and RMP. In this way, we finished the table quickly and without compromising the knowledge from any of the team members. It is worth mentioning that to fill the FMEA, we relied on the provided tables of severity, occurrence, and detection.
Well, this is the process failure mode and effect analysis worksheet. At first, we had the title, of course. Then we have the product, the part, in this case, the bicycle, the project, the team, number 2, the engineer, in this case, me, Juan Daniel Puente, the manager, Juan Pablo Monroy for this team, the FMEA number 1, and the original date, that is today. We start with the process. In this case, the part of the bicycle. We have the frame, the saddle, the seat post, the headset, etc. Then the function of this part. For example, the frame holds the entire bike up and together. Then the failure mode. In this part, we have 3 failure modes per each part. So for the frame, we have a broken frame, a dented frame, and the frame is desoldering. Then the effects. The effects that this failure mode can have in the bicycle and in the rider, of course. The broken frame, the driver can ride. In the dented frame, it doesn't look right. And the frame is desoldering, the accident. Okay, the severity, my partner just explained the tables that we have. So with those tables, we select the severity. In this case, with a broken frame, it's a severity of 10. With a dented frame that doesn't cause anything, you can still ride, it's a 2, and the frame is soldering. It's dangerous to keep riding, so it's a 7. The causes, what can cause these failure modes? Maybe a previous accident, bumps of the bike, wear from use, etc. Then the occurrence. How often this could occur? In this case, a big accident is something that could happen. Bumps in the bike is something that always happen. And the frame is only something extremely rare. So these are the occurrence of these failure modes. The detection control. How can you detect it? By visibly inspect the product, manually inspect it, you can feel it, etc. And the detection. Can you see it? It's obvious in the part of the bike. You need to make an inspection. Maybe it can't be detected, so that's a 10. And then the RPN, that is the multiplication of severity, occurrence, and detection. The action, which is the action you will do, or who will do it. This is the responsibility. Who will do this action that can reduce severity or occurrence or detection or both or the 3. So the RPN in this case could also get low. So you, with this action that the responsible will do, which is the new severity, which is the new occurrence, which is the new detection, and of course, which is the new RPN. We do exactly the same for each part, for each product in this case.
Taking into consideration the analysis made in this activity, we can now use a graphic tool to model and prioritize some few causes that are generating the common effects that can lead to a failure of the bike. To have this analysis, we use the Pareto diagram, which shows us the main causes of the failures on the bike, which are, first, the poor assembly of the bicycle part, also corrosion, a lot of pressure applied to the tire, noise insulation cams, bumps on the bike, lack of cable maintenance, usage, and time. Considering these main causes, we can now focus on them to reduce the 80% of the effects on the performance of the bike by implementing these actions mentioned on the PFMEA and delegating responsibilities to the actors involved.
So now we are going to talk about the recommended actions for the different failures of the process of the bicycle. For this part, we took into account the most important element, that is the RPN, to know the most important failures in which we need to focus to improve and to make a better process. So we got the top 3 and we are going to talk about them. First one, we have the scarred piston rod of the rear shock, the stiff gear shifters, and the puncture of the tire. For these 3 failures, obviously we have different effects and different causes, but we are going to focus into the recommended actions. The first one is to rear shock absorber replacement every certain millage. The second one is to store the bike in a correct place. And the third one is to patch the tire. With these actions, we could prevent the failures and we could have a better process and a better bicycle in which we can ride.
Finally, we would like to conclude with some general comments about this task. The failure modes and effect analysis help us to improve a process identifying potential failures. Also, this tool helps us to propose actions before a problem occurs. In this case, it was a little bit difficult to identify these potential failures because we worked with a bike, a product, and not a process. It is very important to calculate the RPN so we can compare and prioritize the failures or processes that need to be checked. It's important to mention that we need to select the FMEA that best fit our problem or object of study.